carefully plot a polar graph of r equals 1 minus 2 times the cosine of theta. As a review here, we have been working up until now in what is known as a rectangular coordinate system. And in a rectangular coordinate system, we're given an ordered pair x, y, and x will be the distance that you go along the horizontal axis, y will be the distance that you go along the vertical axis. So you may be told to go that far in the x direction and maybe this far in the y direction, and that will put you at this point right here. That is known as the point xy. There is also a polar coordinate system. And in a polar coordinate system, instead of being given an x and a y, you are now given an r and a theta. So the theta is going to tell you what the angle is. So of course this is the usual way from the winding function that you're used to defining an angle. And r will tell you the distance from the origin to the point. So for example, if you want to define the point, say, that is out here, then that point using the polar coordinate system will have a distance r from the origin, and that'll be this length right here, and it will also have an angle theta measured counterclockwise from the horizontal axis. So that's to kind of get you ready for thinking about how to do a polar graph. Now let's erase all of this and we'll start to work on the polar graph. So the first thing that you do, set up your set of axes, and I'll do that right here. Second thing to do is to generate a number of theta r pairs for this particular graph. So the thetas will go up top here and the r's will go below. Start out with theta equals 0 is the usual way this proceeds. So when theta equals 0, we want to plug into this formula and figure out what r is. Well, what is the cosine of 0? The cosine of 0 is equal to 1. So this is 1 minus 2 times 1, and that is a negative 1. And then we move on to another angle theta. Next one will be 45 degrees, or pi over 4. And now what we do is we say the cosine of pi over 4, that's the square root of 2 over 2. So we have 1 minus 2 times the square root of 2 over 2, and that is going to be 1 minus the square root of 2. We'll do one more and then we'll just list the rest of them. You then go to pi over 2 and ask yourself, what is the cosine of pi over 2? Well, the cosine of pi over 2 is 0, so this is 1 minus 0, which gives you a 1. And this will continue as you go forward. I'm just going to put in the angles up top here. 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and we end with 2 pi. The reason we end with 2 pi is 2 pi is going to take us right back to 0 for this particular graph. So filling in the values that we have here, this one is 1 plus the square root of 2. At pi, this is equal to 3. At 5 pi over 4, this is 1 plus the square root of 2. At 3 pi over 2, it's 1. 7 pi over 4, 1 minus the square root of 2. And at 2 pi, we're back to negative 1. The next step is to start plotting these pairs. We notice that the largest value in magnitude of r is equal to 3, so I'm going to put 3 tick marks out in each direction. Let's take the first point. First point to plot is theta equals 0. We know that's in this direction. And r is equal to negative 1. Well, r equals negative 1. Instead of going in this direction, it's going to go in this direction. So that first point is right here. Now, the second point is pi over 4, 1 minus the square root of 2. Well, the square root of 2 is 1.414. 1 minus 1.414 is negative 0.414. So here is our 45-degree line. That's the pi over 4. And we want to go negative 0.4. That puts us about right here. The next one is pi over 2 and 1. Pi over 2 is in this direction right here. And 1 is 1 unit away from the origin. And that's this point right here. Now, all of these are going to get connected. We'll do one more point. 3 pi over 4, maybe 2 more points. 3 pi over 4 is 1 plus the square root of 2. Square root of 2 is 1.414. Add 1 to it, that's 2.414. So at 3 pi over 4, which is in this direction, we are at 2.414. So that's going to be a good distance away from the origin. That might be out here somewhere. And the next one we're going to do is 3. Pi 3, that is. Pi is this direction. We go 3 out to get to this point. Now we're going to start to connect the dots and see what they look like. So what's happening here is the function is starting here, and it goes out like this, through the origin, to here, and then in some sense it undoes. It does coming back, comes back to here, and there it is. Could have done better, but that's not bad. This is one of the more common polar graphs that comes out. They're all given a bunch of fancy names, and these are all done basically plotting point by point and then connecting the dots to get this. A computer is much better than I am at this, but you should know how to do it by hand, and then you'll know what the computer is doing in the background.